solve the equation x power 4 minus 2x square plus 8x minus 3 equal to 0. Now solution. So given equation is x power 4 minus 2x square plus 8x minus 3 equal to 0. Here x power 4 coefficient is 1 and x cube coefficient is 0. So we can write this equation as two quadratic factor as x square minus kx plus p equal to 0 and x square plus kx plus q equal to 0. Now if I multiply these two factors, we should get this equation. So if I multiply this one, we'll get as x square minus kx plus p into x square plus kx plus q equal to 0. So if I multiply this one, we'll get as x square minus kx into x square plus kx plus p into x square plus kx plus q into x square minus kx plus p into q equal to 0. Now if I multiply this one, we'll get as x power 4 minus k square x square plus px square plus pkx plus qx square minus qkx plus pq equal to 0. Now this we can write as x power 4 minus k square minus p minus q into x square plus pk minus qk into x plus pq equal to 0. If I compare this equation with the given equation, we'll get as k square minus p minus q equal to 2 and pk minus qk equal to 8 and pq equal to minus 3. From here we can write as k square minus p plus q equal to 2, and from here if I take k common, we'll get p minus q equal to 8 by k and pq equal to minus 3. Now this equation we can rewrite as k square minus 2 equal to p plus q. Now square both side. So we'll get as k square minus 2 whole square equal to p plus q whole square. This we can raise k power 4 plus 4 minus 4k square equal to p square plus q square plus 2pq. This we can write as k power 4 plus 4 minus 4k square equal to p square plus q square we can write as p minus q whole square plus 4pq. So we'll get as k power 4 plus 4 minus 4k square equal to p minus q we can write as 8 by k. So this will come as 64 by k square plus 4 times of pq. Pq is minus 3. So this we can write as k power 6 plus 4k square minus 4 times k power 4 equal to 64 minus 12k square. So this we can write as k power 6 minus 4 times k power 4 plus 16k square minus 64 equal to 0. If I take k power 4 common, we'll get as k square minus 4 plus if I take 16 common, we'll get as k square minus 4 equal to 0. So from here we'll get k square minus 4 equal to 0 and k square plus 16 equal to 0. So from here we can say k square equal to 4, k equal to plus minus 2, and this is not possible. We got k values plus minus 2. So if I take k equal to 2, we'll get same answer for k equal to minus 2. So we can take any one values. So if I take k equal to 2, p plus q will get as k square minus 2. So this will get as 4 minus 2, that is 2. Similarly, p minus q will take as 8 by 2. So p minus q equal to 4. So p plus q equal to 2 and p minus q equal to 4. If I add it, we'll get as 2p equal to 6. So p equal to 3. If I put p value here, we'll get a 3 minus q equal to 4. So Q value is 3 minus 4. So Q equal to minus 1. So K value is 2, P value is 3 and Q value is minus 1. So if I put K value, P value and Q value, so one factor will get us x square minus 2x plus 3. Another factor is x square plus 2x minus 1 equal to 0. So from this equation, x value will get as minus of minus 2 plus minus root over b square, that is 4 minus 4, a is 1 and c is 3 divided by 2, a is 1. So x equal to will get as 2 plus minus root over 4 minus 12 divided by 2. So we'll get as 2 plus minus root over minus 8 divided by 2. It will come as 2 plus minus iota 2 root 2 divided by 2. So we'll get as 1 plus minus root 2 iota. Similarly, from this vector we can get as x equal to minus 2 plus minus root over b square, that is 4 minus a is 1 and c is minus 1 divided by 2a. So x will get as minus 2 plus minus root over 5 divided by 2. So there are 4 factors. This is your answer. Next problem is if a1, a2, a3 dot 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 an, where n is greater than or equals to 2 are real and n minus 1 into a1 square minus 2n a2 is less than 0, then prove that at least two roots of the equation x power n plus a1 into x power n minus 1 plus a2 into x power n minus 2 plus dot 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 plus an equal to 0 are imaginary. Solution. So given equation is what? X power n plus a1 x power n minus 1 plus a2 into x power n minus 2 plus dot 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 plus an equal to 0. Suppose roots of the equation is alpha 1, alpha 2, alpha 3 dot 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 alpha n. Sum of this equation we can write as sigma alpha 1, that is nothing but alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 plus alpha n, that is given as minus a1. Next is sum of roots taken 2 at a time, that is sigma alpha 1 alpha 2, that will come as alpha 1 into alpha 2 plus alpha 3 dot 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 plus alpha n plus alpha 2 multiplied with alpha 3 plus alpha 4 plus alpha n plus dot 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 alpha n minus 1 into alpha n equal to a2. If I put a1 and a2 value in this equation, we will get as n minus 1 into a1 whole square. So a1 is what? Minus of sigma alpha 1 whole square minus 2n a2. a2 is nothing but sigma alpha 1 alpha 2 and that is given less than 0. So this will come as n minus 1 into sigma alpha 1 whole square minus 2n into sigma alpha 1 alpha 2 is less than 0. Now this we can write as n minus 1 into sigma alpha 1 whole square, we can write as sigma alpha 1 square plus 2 times sigma alpha 1 alpha 2 minus 2n into sigma alpha 1 alpha 2 is less than 0. This will come as n minus 1 into sigma alpha 1 whole square plus 2 times of n minus 1 into sigma alpha 1 alpha 2 minus 2n into sigma alpha 1 alpha 2 is less than 0. This will come as n minus 1 into sigma alpha 1 whole square plus, if I take 2 times sigma alpha 1 alpha 2 outside, so 2 times sigma alpha 1 alpha 2 is outside, this will come as n minus 1 minus n is less than 0. So this will come as n minus 1 sigma alpha 1 whole square plus 2 times sigma alpha 1 alpha 2 minus 1 is less than 0. So this we can write as n times of sigma alpha 1 whole square minus sigma alpha 1 whole square minus 2 times of sigma alpha 1 alpha 2 is less than 0. So this will come as n times of sigma alpha 1 whole square minus outside sigma alpha 1 whole square plus 2 times of sigma alpha 1 alpha 2 is less than 0. So this will come as n times sigma alpha 1 whole square minus, this is nothing but what, sigma alpha 1 whole square is less than 0. To understand this one, we'll use n equal to 4. Then roots will be alpha 1, alpha 2, alpha 3 and alpha 4. So if I put n value 4 and roots, so this equation will become as 4 times alpha 1 square plus alpha 2 square plus alpha 3 square plus alpha 4 square minus sigma alpha 1 whole square, that is alpha 1 square plus alpha 2 square plus alpha 3 square plus alpha 4 square. This minus will take inside, so we'll get minus 2 times of sigma alpha 1 alpha 2, that is less than 0. So this is 4 times and this is 1 times. So this will come as 3 times of alpha 1 square plus alpha 2 square plus alpha 3 square plus alpha 4 square minus 2 times of this we can add as alpha 1 into alpha 2 plus alpha 3 plus alpha 4 plus alpha 2 into alpha 3 plus alpha 4 plus alpha 3 into alpha 4 in bracket less than 0. So this will come as 3 times of alpha 1 square plus 3 times of alpha 2 square plus 3 times of alpha 3 square plus 3 times of alpha 4 square. If I multiply minus inside, so we'll get as 2 times of alpha 1 alpha 2 minus 2 times alpha 1 alpha 3 minus 2 times alpha 1 alpha 4 minus 2 times alpha 2 alpha 3 minus 2 times alpha 2 alpha 4 minus 2 times alpha 3 alpha 4 is less than 0. This equation we will try to make as perfect square. So for 2 alpha 1 alpha 2, so we will take as 1 alpha square 1 alpha 2 square minus 2 times alpha 1 alpha 2 plus for this term we will take 1 alpha 1 square plus alpha 3 square minus 2 times alpha 1 alpha 3 plus for this term we can take as alpha 1 square plus alpha 4 square minus 2 times alpha 1 alpha 4 plus for this term we can take as alpha 2 square plus alpha 3 square minus 2 times alpha 2 alpha 3 plus for this term we can take as 1 alpha 2 square plus alpha 4 square minus 2 times alpha 2 alpha 4 plus for this term we can take as 1 alpha 3 square plus alpha 4 square minus 2 times alpha 2 alpha 4 is less than 0. This will become as alpha 1 minus alpha 2 whole square plus this will become as alpha 1 minus alpha 3 whole square plus this will become as alpha 1 minus alpha 4 whole square plus this will become as alpha 2 minus alpha 3 whole square plus this will become as alpha 2 minus alpha 4 whole square plus this will become as alpha 3 minus alpha 4 whole square is less than 0. So this equation we can add as sigma sigma I equal to 1 to 4 j equal to 1 to 4 alpha I minus alpha j whole square. Similarly, this equation we can add as sigma I equal to 1 to n sigma j equal to 1 to n alpha I minus alpha j whole square is less than 0. So this equation we can write as alpha 1 minus alpha 2 whole square plus alpha 1 minus alpha 3 whole square plus alpha 1 minus alpha 4 whole square plus dot 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 alpha n minus 1 minus alpha n whole square is less than 0. We can say this equation is true if at least one term is less than 0. So we can take any one term should be less than 0. So we can take suppose this term is less than 0. So we can say alpha 1 minus alpha 2 is less than 0. So we can say alpha 1 minus alpha 2 must be imaginary. Alpha 1 minus alpha 2 is imaginary if alpha 1 comma alpha 2 both are imaginary or one of them is imaginary. But this is not possible because coefficients are real. So imaginary roots are always in pair. You can say at least two roots must be imaginary. So this is your answer.